I wanted to ask you, how'd you come up with this? Let me put a little banner up, switch the banner. Because I do think this is a fresh idea. I think, I hear complaints from time to time is, oh, it's the same old argument over and over again. And I think you mentioned it too. Like you got some you made some good impressions when you went to the conference with this because people had not seen this before. How did you come up with it? Two-parter question here. How did you come up with the idea to do this particular experiment? And why did you choose 3 hours and 45 degrees? Why not like 2 hours and 60 degrees or like 4 hours and 30 degrees or something like that?
I think those are great questions, and especially, how did I come up with it? Those are great questions. And so when I first, I heard about flat Earth, I had to look into what I know. And I think that's what kind of a lot of people would do is, what relevance does this have? How can I understand this, and how can I test it? In other words, Can I test this?
Yes, that's what my channel is all about, by the way. How can I test it?
How can I test it? In other words, you tell me that the Earth is flat, okay, or you tell me the Earth is a globe. So I had to, and this took me about 4 years. So it wasn't something that came up because I was introduced into flat Earth about 2015. 2016, I understood some things about flat Earth, and it convinced me to say, okay, now I gotta look into this. I'm gonna test it. How am I going to test it?
Mm-hmm.
I had to look at my background, artillery, geometry. Is this a geometric form? In other words, okay, the Earth is a geometric form. The sun is a geometric form. Okay, so it's going to have to do with geometry. Geometry is going to help give me the answer. Now, what about the process and application? So I looked at other experiments, and a lot of people say, long distance photography. And so there's a big hoo-ha about, well, I can see farther than what I shown on a curve.
Yeah, I've seen those.
Some valid point. And then other people say, well, that's a mirage.
Right. Yep. That's the problem, isn't it? Right. It's
so yeah. When we look at that, I kind of look at things kind of tactically. Okay. So now I'm at lower elevations. I'm going to get interference. And even military science talks about it as well. And that's why we go up at higher angles to get more clarity. I want to go above 15 degrees. And when I went to the Flat Earth Conference in 2019, I talked to some people about the idea. Nobody knew anything about it. And I just wanted to see what people knew, if anybody had thought about it. So then I knew, okay, I've got my work cut out for me, because now I'm going to have to not only convince the Flat Earth community, then you've got the other communities after the Flat Earth community, or other people that are looking into it. And guess who I get the toughest questions from?
Do you get them from the Flat Earthers?
Yeah.
Really?
They're like, okay. And I get diagrams. You are the first guy to send me a video with a diagram. Can you believe that? I asked diagram.
Unfortunately, I can believe it. I think what you get is, for the most part, what you get is a flat earther comes forward with his talk, and then the globers just go make fun of it, or they just deny it, or they just shut it down, and they don't really. Most of them don't really want to pick at it.
Yeah.
I think vice versa, very much true.
I think because I think it makes people uncomfortable too.
I think mostly it comes down to most people don't make these decisions of like globe versus flat. They don't make that based on evidence. They just decide, and then they go picking up the evidence that supports them.
Yeah. And to be honest, I really didn't care. And I didn't have a lot of interest before I they hit me up with it, and I was like, okay, finally, it bugged me. They threw it at me enough where I said, okay, I got to look at it. All right. And like I said, because I laughed at the idea, but anyway, you're the first guy that sent me a diagram, because I said, well, send me a diagram. Show me what you're talking about. I get crickets. So I'm like, I'm gonna talk to this guy. He took the time to send me a video diagram. Okay, this guy's genuine, openly, questioning, or he's interested in it, and I appreciate that. I look at it and say, now I'm going to take the time and I'm going to try and explain my point to this individual, because at least he took the time, to do that, to set it out. And I appreciate that. I really
Cool.
do.
Very good.
I think that's very genuine. And this day and age, that can be difficult.
Yeah, it really is. And that's what I'm trying to do here. I'm trying to be an example for everyone on both sides, that we can talk about this, and ultimately we could theoretically come to an agreement. If we go based on evidence instead of based on our gut, we should look at the same evidence and come to the same conclusions. Ideally, that's what we'd be hoped for, right?
Yeah, understanding. So when I look at that, again, military science, we want to get away from 15 degrees and below to the ground, because we're going to have atmospheric pollution, all kinds of other stuff. So I said, okay, I'm going up high. In other words, now I'm going to use the sun, because the sun is the ultimate aiming reference. The military used the hell out of the sun. It wears it out. So I said, we're going that route. So we're going to use the sun aiming. It's the ultimate aiming reference. It's the wet dream of wet dreams, if you're talking about wet dreams. So it doesn't get any better than that.
Okay.
Sweet.
Cool.
So
that I think answers one of the problems I have with your thing is, why didn't you just use sunrise, sunset? Why 45 degrees? And it seems like your answer is, down near the horizon, funky stuff happens, and we know that. So let's just get up away from the horizon. We're not going to talk near the horizon. So 45 degrees is you're like halfway. It's like compromise land.
Yeah. And it's kind of an easy number to work with. When I looked at it, I said, it's easy number, 45, you're at 45, 90. Okay. Too easy right there. You got to kind of get that process, though. In other words, you have to get that understanding. So that's why I went up high. It deals on my experience and my knowledge with celestial survey. So now I'm going up high. What was that? Hopefully that answered your question.
Yeah, I think it really does. I think it's a good answer. You ever try like 60 degrees instead of 45? You ever try like 2 hours later, 1 hour later instead of 3 hours later?
You could, but 45 just seems to work a whole lot better. In other words, if I look at those angles, because again, I'm looking at what's the easier process, what are kind of manageable or easier numbers to kind of work with. 45 is kind of like your halfway point. So in other words, excuse me, if I'm on a ball or a globe, I'm oriented at 45 degrees. It's real simple to say, okay, I got 45 left to work with. It doesn't get any easier than that, really. And that's why I use that practical exercise. And there's also the practical exercise on my website, and I talk about that. The flat Earth model is easy because there is a line of parallel. We have to understand line of parallel, and that's a limit. In other words, if I asked you in the heliocentric model, in your understanding, what would tell me if that model is out of tolerance? How would you go about that using geometry in the sun?
Have done that recently. There's actually many different approaches. I like yours. I like this approach. Although I think I'm going to point out in a bit that there's a problem with it. It's actually, I don't agree with it.
Mm-hmm.
And we'll see why. But the approach we took actually on this channel, did we do it in the summer or the spring? We did it in the summer. We did it last summer. Mm-hmm. Had a bunch of people all around the world measure the elevation of the sun at local noon. And then we tracked what was the elevation of the sun at local noon at different latitudes and graphed that, and one of the viewers created a lovely interactive display where you start with a flat Earth, and then it shows all those elevations on there. And then you can, with a slider, you can bend it down into a curve and see what those sun angles do. And it was beautiful, really. was wonderful.
Cool. I'd be interested to see some of that information if you're willing to share it or anything that you have on it. I'm always interested in looking at data like that. If you have it. If not,
Yeah,
okay.
I'd have to dig that back up. Take me just a minute. Maybe we'll do it like at the end of the show or something. We'll
No, I
circle
mean,
that back
you
up.
don't got to do it right now. If you have it, I'd like to kind of look at it and just
Uh-huh.
look at, what and you can kind of explain your process in the email, or if you want to talk about it, in another meeting, we can do that. I'd like to look at that.
Yeah, I thought that was really cool. Of course, I got the usual arguments from the other side, which mostly, frankly, aren't talking. They don't want to talk about the evidence or what it shows. They
Mm,
just want it to not be true, um,
yeah.
because you won't be surprised that when you show it on a flat plane, you graph all those angles on a flat plane. They don't line up. They're every which way. And then you curve that thing around to a ball, and then all of a sudden they line up and they become parallel. And you're like, oh, that's why people think it's parallel. Um, and that's my point on it too, is not to say, look, I just proved it. I didn't prove anything. I just explained why we think this. I showed what the evidence is that makes you think,
Mhm.
gosh, maybe these lines of sunlight are actually parallel and the Earth is curved.